Mrs. Retner, and I am going to take you through our next topic in trigonometry, which is angle of elevation. Angle of elevation is pretty much bringing together what we already learned about in terms of how we find sides and angles with right triangles and incorporating word problems. Don't worry, I know word problems can be kind of daunting, but we'll take our time and make sure we get all the pieces and all the bits of information that we need. First of all, if you do not remember your three main trig functions, go ahead and write those down. Those still exist, they still apply. We have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We're still going to use these three trig functions because once we develop our picture, that's how we're going to solve. We have to figure out what's opposite, what's adjacent, what's the hypotenuse, and then kind of go from there. So write those across your top of your piece of paper and let's get started. So, angle of elevation, to give you a definition, is the angle between the horizontal and your line of sight, specifically when you are looking up. Okay, elevation, try to think of we are elevating or we are looking up. So I have a basic kind of picture here for you to kind of break this down. So here is the observer. This is where we're looking. This observer right now, the eye is looking straight forward. That is our horizontal line of sight. Now, if we were to take that eye and kind of tilt it upward to look at the object, that would have created this angle of elevation. Okay, you could do this right now sitting in your chair at home. If you're sitting at home, look straight ahead. When you look straight ahead, that's your horizontal line. Now look up at the ceiling or look up at whatever's, on the ceiling, maybe a light fixture. Your motion of taking your head from the horizontal line to the ceiling or to a light fixture on the ceiling, that is creating an angle of elevation. We are looking in the upward direction. And that is how all of our problems are going to be talked about, where we're looking up at something, maybe in the sky or on the top of a building or something along those lines. So let's get started with our first problem. Here it is. We have a hiker that is standing 220 feet from the base of a hill. The angle of elevation from where he is standing to the top of the hill is 29 degrees. How tall is the hill? So remember, we need a right triangle. So somehow we need to take this information, put it into our right triangle, which I have in front of us, and then obviously solve the problem. So here's what we know. We know we have a hiker, and we know the hiker is standing 120 feet from the base of the hill. So the base of the hill means the bottom of the hill, which would imply that we're talking about the ground or this horizontal. So here's our hiker, my little stick figure here. Okay, he is standing on the ground, and this distance right here is 220 feet because this is my hill. This vertical line right here, that's representing my hill in my right triangle. Okay, what are we going to label this side? Well, the question is asking how tall is the hill. So if this is my hill and I have to figure that out, there's my x. Okay. Now, the last piece of information we need to incorporate is the 29 degrees. The sentence says the angle of elevation from where he is standing, so here's my hiker, this angle of elevation from where he is standing to the top of the hill, this would be the top of the hill, so this angle right here is 29 degrees. There's our picture. There's our right triangle. Now we need to use our trig functions. So if you remember back when we did this, you have to think about, okay, here's my angle, 29 degrees. This side is considered opposite. This side, the 220, is adjacent. Opposite over adjacent is my tangent function. So I'm going to do tangent 29 equals opposite over adjacent. Okay, remember we simply put this side over 1 and we are going to multiply both sides by 220. The 220s are going to cancel out over here. We are left with x, and now we have 220 times tangent 29. This is where you're going to pick up your calculator and you are going to plug this into your calculator exactly how you see it. Now make sure the calculator is in degree mode. So if you don't have it there, hit your mode button. Make sure you're in degree mode. Type in your 220 tangent 29 and you should get 110.9. We will round to the nearest tenth, 110.9 feet. Okay, any questions there? You can go ahead and read through it again, look over how we solved it, and then we'll move on to the next problem. Okay, next one. Alex is standing on the ground and looks up to see an airplane flying in the sky. So Alex is on the ground. So Alex is over here. Okay, there's an airplane in the sky. I'm not going to try to draw an airplane for you. I'm just going to write the word airplane. I'm not an artist. I definitely don't expect you to be. If the airplane is flying at an altitude of 2 miles, altitude is the same as height. So meaning the height of the airplane is 2 miles. And the distance along the ground is 5 miles from Alex to a point directly below the plane. So what that's saying is that the distance on the ground from Alex, here's Alex, to a point directly below the plane is 5 miles. Okay, here's our right triangle. What is the angle of elevation that Alex has to look to see the plane? So if Alex is down here, the question is, what is this angle that Alex has to look in order to see the airplane? All right, there's our picture. There's our right triangle. So same as before, we need to figure out what function are we going to use. Starting with x to our 2 miles, this is opposite. This is adjacent. So if you notice, again, we are going to use tangent. So tangent x equals opposite over adjacent. Now, since we are looking for the angle, this is one where we are not going to multiply both sides by 5. We're actually going to go right to our calculator, and we have to do that inverse tangent. You're looking for that tangent -1 on your calculator. So you usually have to hit the second button and then hit tangent for it to show up. And then you'll do 2 divided by 5 in your calculator, and you get that x equals 21.8 degrees. Go ahead and pause the video if you need to, look over the problem, and then we'll move on to the next one. Example number 3, a slide has an angle of elevation of 25 degrees. The end of the slide is 60 feet from a stairway beneath the top of the slide. How long is the slide? Okay, so we have a slide, we have a stairway. We know that the end of the slide, so if you think about in real world, a slide is typically going to be on an angle, so that's going to take place of our hypotenuse here. So since we have to figure out how long the slide is, that's going to be our x. Okay, then we have this sentence that it says the end of the slide, so this would be the end of the slide, is 60 feet from a stairway beneath the top of the slide. So if this is the end of the slide, this is the top of the slide, this end is 60 feet from the stairs, because you have to walk upstairs to get to the top of the slide. That end of the slide is 60 feet away. Last piece of information is angle of elevation of the slide, 25 degrees. So if this is our slide, the slide is going up. This angle, 25 degrees. Okay, so there's our picture. I can put this over here. Here's our slide, just so we are all on the same page. All right, let's solve it. So 25 to our x, this is actually the hypotenuse. Remember, the hypotenuse is directly across from the 90 degrees. Then we have 25 to our 60. This is adjacent. So no tangent this time. We are actually doing cosine. So cosine 25 equals adjacent over hypotenuse. So multiply both sides by x. If you remember in our solving, this side's going to cancel. We have x cosine 25 equals 60. And remember, we need to get x by itself. So we are going to now divide by cosine 25, divide cosine 25. Cosine 25s will go away. This is where you're going to pick up your calculator. This is what we're plugging in. So 60 divided by cosine 25, you should be getting 66.2 feet. All right, feel free to pause the video, read through it one more time, and then move on to the next problem. Okay, last one. Example 4. A building. A building is casting, a building that is 75 feet tall is casting a shadow 61 feet long. What is the angle of elevation that the sun makes with the ground? So, in the real world, think about a building. A building is typically vertical. We don't tend to see very many slanted buildings. So, that means this side of our right triangle, that is going to be our building, 75 feet. Now, also think in the real world, where are shadows? Shadows are typically on the ground. So here's our shadow, 61 feet. Okay, 75 feet. The sun is typically up here in the sky, right? So the question is, what is the angle of elevation the sun, so this would be the sunbeam, is making with the ground? Okay, so there's our right triangle. Again, our building is our straight up and down, and then the shadow is our horizontal on the bottom. All right, same as before. This process never goes away. X to 75, this is opposite. This is adjacent, so we will be using tangent again. Tangent X equals opposite over adjacent. Again, we are looking for the angle, so we are not going to be multiplying both sides by 61. We are reaching right for our calculator, and we are plugging in the tangent, inverse tangent. So remember, you probably have to hit the second button first, and you're going to plug this in. It should look exactly like that on your calculator, and you should be getting 50.9 degrees. So feel free to pause the video, rewind the video, go back and look at all 4 of these problems. When you're done and feeling good about it, go ahead and do the required homework, and you will be good to go.